Yes, hi to everyone. Dear students, today we are going to discuss about the electric flux, which is the one of the most important lecture for our JEE, NEET and EAMCET and Karnataka KCET also. Okay. So first let me discuss about the basics. What is meant by electric flux? To calculate the electric flux, first area is required. How to calculate area vector, and area is a vector or scalar, and what is the direction for area vector. So these all things we're discussing. Based on that, first I'm going to use some basics, then we're going to discuss about the numericals. So sharply let me get into the class. Fine. So first we are going to discuss about what here in this case, what is meant by electric flux we are going to discuss. To discuss what is meant by electric flux here, in this first you should know what is meant by area. Area is a vector or scalar. We don't know so far. You might be thought like there is a scalar, but there is a vector quantity. How to find area vector magnitude everyone knows. Length into breadth, or it is something. For example, sphere means 4 pi r square, and if it is a disk means 4 pi a square or pi r square, we might be learned like that. But here in the physics we should learn area is a vector quantity also. You should know actually area is a vector quantity, sir. That's okay. You said area is a vector quantity. Then how can I decide the area vector, sir? Basically surface area can be divided into two types, area. One is for open surface, other is for closed surface. Outright area vector we should learn, For open surface, how can be area vector you can choose means you can choose perpendicular to surface, and for closed surface what we can choose, we can choose outward normal as the area vector. Sir, can you give me example? For example, I am taking here one open surface which is lying in xz plane. So to the xz plane, which is perpendicular direction, it can be y direction, sir. Can't it be minus y direction? We can take both, sir. Yes, sir. We can take both because both are perpendicular. I am taking area vector, for example. Like this I am taking. This is perpendicular only parallel to y. So I am taking anti-parallel to y. You can take that is also perpendicular to y only, like this. Yes, both are perpendicular only. Then what I can write? Area vector we can write it. Okay, here also what you can write, area vector. This is along positive y direction, this is along negative y direction. For the open surface, area vector should be perpendicular to the surface. Either it can be outward or inward, either it can be upward or downward. So once you choose an upward direction, until that problem will solve over, you should use that only, outward direction only, not for entire physics. Okay, for second problem, whatever direction you choose now, that's okay. Downward if you choose also okay. Okay, sir, we understood for plane surface. Then what about the curved surface, sir? For the curved surface you check, okay, curved surface you leave, first closed surface you take. For closed surface what, outward normal, you should take one normal to the surface outward direction. That will give the direction of area vector. So for this cuboid, cube what I am taking, like this I am taking area vector. Yes sir, we can take. For this face, I am taking like this. Yes sir, we can take. For the upward face, like this. For below face, downward. For front face, out of the board. For back face, into the board. Like this we can choose area vector. So everywhere if you observe here, what will happen? They should be normal to the surface, angle should be how much, 90. Check here with the surface what angle, 90. How much, normal 90. So this is area vector, this is area vector, this is area vector, this is area vector. Back side one will go to the into the screen. Okay, this is area vector. Sir, can you draw the in for the cylinder, sir? Cylinder also closed here, yes, closed. This is plane surface, and closed. Closed means we should take only outward. I told you outward direction like this. We got it. Okay. For this plane, outward like this. For this curved surface, a cylinder. This is curved surface. It should be outward normal. It should make with the surface normal 90 degrees. It should make. So if you observe clearly, this is area vector, sir. This is area vector, sir. This is also area vector. What angle it makes? 90 degrees. Sir, let me take one sphere, sir. For sphere, how to draw the area vector? Teach us, sir. How to draw means. See, for sphere, very simple logic. I'll give you. Follow that logic, you will get answer very easily. Area vector direction. Choose the center. From the center, wherever you want to find area, we just draw the one radius line. And extend the radius line. If you extend the radius line, what will happen? This is the radius line. I'm extending this radius line. That is the direction, area vector. Sir, about this point, can we find area vector? Draw the radius line and extend this. Sir, does it follow the rule which you told me earlier? Closed surface, outward normal. It's following. You check here. What angle it's making? 90 degrees. What angle it's making? 90 degrees. So for the sphere, this will be very easy, we just take the one line which is extending the radius. That will give obviously 90 degrees with the surface, normal to the surface, Yes sir, we learned what is the area vector. Can we learn about the electric flux? Yes, we are going to learn about the electric flux. What is meant by electric flux? Electric flux is nothing but what you check here, Electric flux is a measure of the flow of electric field through a given area. Through given area, how many number of field lines passing? How much field is passing? That measure is called what? Electric flux they are saying here. Okay. Often visualized as the number of electric field lines passing through that area. Okay, for example, you look at this example, in this example, one area A is there. Okay, area vector is perpendicular to surface, like that I given here. So in this case, what happened, electric field is like this, like this electric field I applied. Not exactly perpendicular to the area. But in mention, what I mentioned, electric field is passing through area mentioned, I should take perpendicular to the area vector. So flux out right means flux equal to simply I can write here, flux equals to, sir, I can write like E vector dot A vector, sir. Sir, why did you choose an E vector dot A vector only? Why can't E vector cross A vector? Means electric field is a vector quantity, area also vector quantity. So far we just defined just now only. But flux is a scalar quantity. From the two vectors, if you want to get a scalar, no, which product we have to use? Dot product or cross product? Dot product or scalar product we should use, or simply this E is there, break this E and take along the A direction, in the place of E, what I can write, E cos theta, that's why. So flux equals to, expand this E, your dot product, what will get, EA cos theta will get it, sir. EA cos theta. Yes, sir, that's okay. Can we write SI unit, sir? How can we write SI unit, check SI unit. SI unit, electric field into area. What is electric field, Newton per coulomb into area is what, meter square. Newton meter square per coulomb, which we can write it. Sir, can we write one more unit? Yes, one more unit we can get it. Electric field potential relation, what we know? E equals to minus dV by dr, means what will get in this case, dV by dx. SI unit, what will get, volt per meter. If you use this SI unit, what will get, R. Okay, what we can write, another unit, volt per meter into area unit is what, meter square, meter square. 1 meter will get cancelled. Volt into meter also will get, SI unit of the electric flux. Electric flux. Sir, can't we calculate the dimensional formula for this? Why can't we calculate dimensional formula? Let me check here. Dimensional formula, flux, important. They will be asking in JEE Mains. Many times they asked you. Like matrix matching, they'll form. Okay, or match the following. So, Newton indicates what in a force. Sir, what is the force dimensional formula? You know, everyone? Mass into acceleration. M power 1, L power 1, T power minus 2, sir. Meter square. Meter square indicates the length, So, what is the length dimensional formula? L square divided by Coulomb. Coulomb indicates this charge, sir. What is the charge dimensional formula? A power 1, T power 1. Do not by heart the dimensional formula. How to write the dimensional formula? You learn, okay? Do not by heart it. So flux equals to, what you can write, here M power 1 is there, sir. Yes, L power 1 to L power 2. L power 1, L power 2, 3 will become what, L power 3. This is what, T power 1, if it goes to numerator, what will you get, T power minus 3. A power 1 will become what, A power minus 1, which we got it here, Okay, sir, we got it the flux formula, EA cos theta or E vector dot A vector. SI unit, Newton meter square per coulomb also we can use this, or volt per meter, volt into meter also we can write it. And flux dimensional formula we got like M power 1, L power 3, T power minus 3 into A power minus 1, we got it, sir. And we did not do by heart. This T power 1, if we take to numerator, T power minus 1 it will become, that's why T power minus 3. Okay, fine, sir. Let me take in these examples, how to learn the flux, how to calculate the flux, let me teach you. So, here if you observe clearly, this is x-axis, this is y-axis, this is z-axis we are taking, So, this sheet is lying on xz plane, Okay, if the sheet is lying in xz plane, area vector will be which direction, perpendicular to that, I am choosing upward direction in these examples, okay. You can choose downward direction also, not a problem, okay. Fine, if you choose upward direction, theta is 0, Sir, what is flux formula? What is flux formula, Flux equals to what we can write, EA cos theta. EA cos theta, theta value much, 0. So, flux equals to what, E into A. I got the positive value. Okay. If electric field is getting into the sheet, area vector is outward only I am choosing. So what is the flux? Let me take in this example, flux equals to EA cos 180, sir. Cos 180 is how much, Everyone knows that, sir. Minus 1, sir. So flux equals to M, right, minus E into A, we can write it, flux in this case. If electric field is along the plane, on the plane electric field is passing, area vector is perpendicular to the plane, so theta equals to how much, 90. Flux equals to what we write, EA cos 90 we can write it, so cos 90 how much, 0. Sir, flux equals to cos 90 is 0, sir. 0 into anything will be how much, flux equal to 0. Whenever electric field is on the surface, flux due to that surface is 0, I proved you. Electric field is on the surface, area vector is perpendicular to the surface, and theta is how much in this case, check, 90, sir. Theta 90 means flux equals to EA cos 90, flux equals to 0, we got it. Sir, you may get the doubt. If I place the charge on any sheet, sir, what will happen to flux? I place the charge Q here, Electric field lines are passing on the sheet like this, sir. Yes, sir. Area vector will be out of the sheet, yes, sir. What is this angle, This angle should be much, 90, sir. So flux equals to what, Same kahani. What is that? EA cos 90. Cos 90 is how much, 0, sir. Therefore, flux phi equal to what will get, 0 will get it, sir. So, if electric field is passing along the plane, flux equal to 0. If a charge is placed on any place, no, on due to that face also, due to that surface also flux how much na? Zero. Any important point. And when electric field is leaving, no, that is called leaving flux. Leaving flux means what you got it positive. When electric flux is entering, no, what we can call it na? Negative flux. That's why you conclude the point. If you see the leaving flux anywhere, na, leaving flux. Leaving flux, what you have to consider means leaving flux you should consider as negative or positive. Na. Leaving check in this case, electric field leaving means flux also leaving. That is positive. If anywhere flux is entering, na, positive. Okay, entering flux. Entering flux, you check in the example, na, what we got it, electric field is entering means flux also entering. What we got, na, negative. Do remember, if flux is leaving, positive sign you should take. If flux is entering, negative sign you should take. In JEE Mains, one question they asked you based on that. Basic question they asked you. Okay, fine. Next, if electric flux, this is we did for uniform field, nana. If electric flux, if they ask you non-uniform field, very important for your NEET and JEE and EAMCET and KCET also. So how to do that means, let me check here. D phi you should equal to what we write, nana? E vector dot dA vector we should write, nana. In this case, electric field is non-uniform field we are considering, nana. Non-uniform field, electric field considering. Uniform field. Then how to approach the problem means, you just integrate both sides, nana. If integrate both sides, what will get, nana? Integral d phi is equal to what will get, nana? Integral E vector dot dA vector, sir. Okay, integral d phi going to be how much, nana? Integral dx is x, integral dy is y, integral d phi going to be how much, nana? Phi. Therefore, what will get, nana? Closed integral E vector dot dA vector, we can take it, nana. If both are same direction, electric field is parallel to the dA vector, then what will happen, nana? Theta value much, nana? 0 degrees. In that particular case, not even dot product, nana, EDA we can write it, nana. Which case observe carefully, when electric field is parallel to dA. If electric field also z direction, dA also z direction, theta is 0, na, cos 0 much, nana, 1, and the EDA we can write it, nana. That's why we can write the EDA. Fine, let me go to one problem here, nana. This problem they asked in NEET exam, 2 times they asked you. See, you just check that one square sheet they given, whose side length is L they given. Electric field passing on the plane like this, nana. If electric field passing on the plane, nana, how does area vector will come, nana? Area vector will come out of the board, sir, out of the screen for you. So what is angle, nana? Electric field angle between these both is how much, nana? 90. Therefore flux equals to what you write, nana? EA cos 90. Cos 90 is how much, nana? 0, nana. So flux equals to how much, nana? 0. So look at this question. Within a second we solved it off because your basic is strong now. Okay. Area vector for this plate is the sheet is what, nana? Out of the board, or for you people out of the screen. Let me go to another question, nana. This is also one of the PYQ. Okay. Okay. Area is 100 centimeter square given, nana, is placed in uniform electric field 100 Newton per Coulomb in such that angle between area vector and electric field what they given, 60 degrees. Then find the flux. If not the lux, find the flux. Okay. Okay. So area vector they given, nana. How much is area vector they given? Electric area value 100 centimeter square they given. 100 centimeter square, if I write in SI unit, what I write, nana? 100 into centimeter whole square. 1 centimeter equal to 10 power minus 2. Square of that will be how much, nana? 10 power minus 4, sir. Means what you write, nana? Meter square unit we writing. So area equal to what we written, nana? In this example, nana? 10 power minus 2 meter square, which I written, sir. Electric field value how much they given, nana? Yes, sir. They given 100 Newton per Coulomb, sir. Angle between these both what they given, nana? Theta equal to 60 degrees they given, sir. Substitute in this equation, flux equals to E value. What is E value, nana? 100 into area value much, nana? 10 power minus 2 into cos theta. Theta value much, nana? Cos 60. Cos 60 much, nana? 1 by 2. So flux equal to what will get, nana? 100 into 10 power minus 2 will get cancelled 1 by 2. It's nothing but 0.5, nana. Clearly they mentioned here electric flux, nana. But units they given Weber, nana. Weber is a unit for magnetic flux. That's why only this what is that? Unit is wrong. Don't worry about that. We can write volt into meter only. We can write it. So which option is correct in this case, nana? 0.5, na? 0.5 volt into meter we can write it, na? Which option is correct, nana? Option A is correct, sir. Let me go to another question, nana. See, this question is I am taking from EAMCET, nana. It's nothing EAMCET, nothing JEE, nothing NEET, nana. Physics we are learning. Keep in the mind. Okay. In this example, what they given, nana? A square frame of side 0.05 they given, nana. Side square frame they said. Side length how much they given, nana? A equal to how much, nana? 0.05 meters. Means what I write, nana? 5 into 10 power minus 2 meters side. Area means what I can write, nana? A square. Square of this is going to be much. Side square. 25 into I can write like 10 power minus 4 meter square, sir. Very good, nana. Electric field they given. How much they given, nana? 10 root 2 they given, sir. And Angle between them how much they given nana? 45 degrees. Then start substituting the values. So flux equals to E value how much they given nana? 10 root 2 they given, sir. That's okay. Area value I calculate how much nana? 25 into 10 power minus 4 we calculated nana. Cos theta. Theta value 45. Cos 45 1 by root 2. We should know basic mathematics. This is 1 by root 2. Root 2 will get cancelled nana. 10 into 10 power minus 4. 10 into 10 power minus 4, 10 power 3 will become na 25 into 10 power minus 3. Unit we can write like volt into meter. Nana. Sir, which option is correct? Check in the question which option is correct. 25 into 10 power minus 3. Option B is correct. Nana. Very simple question. Nana. You just need to know how to find the flux formula. Okay. You need to apply that and how to calculate the area. Basic mathematics we should know in this question. They may ask you in KCET, they may ask you in NEET, they may ask you in JEE also, such kind of questions. Okay. Fine. Let me go to next problem. Nana. Electric flux through the surface element means they mentioned area element they mentioned. Symbol whatever they given, it does not matter. Leave about that. 5 I cap means electric field is area vector is along x direction. Means that is in the which plane? YZ plane. Placed in electric field of E equal to 4 I cap plus 4 J cap plus 4 K cap. I written electric field, I written area vector. Dot product. What is the dot product? Multiply I with I, J with J, K with K. So I with I means how much? 4 5 is 20. What will get 20 I cap or 20 A. Flux is a scalar na 20 dot product plus 5 J cap here no J 0 plus here also 0. So flux equals to what we can write and flux equals to E vector dot S vector sir area vector 20 plus 0 plus 20 how much 20. So answer going to be 20 units nana. Which option is correct nana? Sir we understood that option B is correct here sir. If we go to next example nana, if you go to next illustration, if electric field is this much, okay, that's we written E equal to 5 I cap plus 4 J cap plus 9 K cap. The electric flux to the surface of 20 unit lying on YZ plane. Surface area value they given 20 units. Okay, that's okay. But lying on which plane nana? YZ plane. Area vector is always perpendicular to the sheet na. It is sheet is lying on YZ plane means electric field along which direction? X direction. So in that case what will get nana? What I can write nana? We can write 20 I cap we can write it nana. So if you multiply this thing nana, dot product we are doing na. So E vector dot E vector equals to 5 into 20. Okay, 5 into 20 how much nana here in this case you check ra 5 into 20 yes they given 20 only. Okay, 100 5 to the 100 na 100 plus 0 plus 0. So flux equals to what you can write nana? Flux equals to E vector dot A vector sir. So flux equals to what you get nana? 100 units whatever they given units sir. Okay, Uttar Pradesh engineering entrance they asked you nana in 2009, but very basic question they can ask to guarantee such kind of questions in NEET exam also. Okay, please check the question how to solve. Fine. Let me go to next example. I given one illustration here nana. X Y Z nana. Okay, I given see sir y should come here. Don't get confused. Coordinate system is our wish nana. We can choose however you want. No, you can write that and you can solve the problem. Okay. In xy plane, I place the disk nana. What is the flux passing through this fellow? If electric field is given this much, you got the electric field value. How much electric field value they given? E equal to what they given now? 2x I cap plus 3y j cap plus 4k cap. Means along the x direction, y direction, flux is changing. Sorry, field is changing. Area vector how to check nana? Sir, I got that direction is nothing but perpendicular to surface means it's along z direction sir. Okay, direction area is outward z direction. How much is area value? A equal to what you get nana? Magnitude pi into r square sir. A equal to pi into 1 square is how much nana? A equal to 1 only right? 1 means pi. Pi which direction? Along z direction. Z direction means what will get nana? Plus j cap. I will get a wrong sir. That is z direction plus k cap we should write sir. Yes, very good. First you learn how to avoid the mistakes sir. Okay. So here z direction ichi manamu. So z direction we given here. If you write the j cap, no, that will be wrong. Along the z direction we should write which direction nana? K cap we should write area vector. So area vector equal to what you can write in this example nana? I cap not there, j cap not there, plus what is there nana? Pi k cap. Then do the dot product for this again. If you do the dot product for this again, what you can write nana? E vector dot A vector is equal to pi into 4 is how much nana? 4 pi nana. So flux equals to right nana? Flux equal to what we can write nana? Flux equals to E vector dot A vector. E vector dot A vector is much nana? E vector dot A vector equal to what will get it here? 4 pi. So flux equals to 4 pi unit volt into meter, which we can write it here sir. Let me go to next lecture, next slide nana. So electric flux. This sheet they given here. Where does this sheet is lying? Your doubt actually. Where does this sheet is lying means I am telling that YZ plane sir. I am telling YZ plane. How come you will tell that YZ plane sir? I am having confusion. Nothing. Observe this now. What I am doing here. I am taking the sheet. I am placing here. Now you realize that. Where does it lying? If It's lying on yz plane, na? Yes, sir, it's lying on yz plane. I'm taking back to as it is where it is earlier. Okay? Yes, it is here. Now what they're asking, na? Find the flux here. It is lying on yz plane means area vector will be along which direction, na? X direction. Clearly you see that along the x direction only we got it area vector. Okay, sir, area vector we got it here. And electric field also along x direction we should take. Along y direction if you take, na, flux will become how much? 0. Because area vector along x direction, y direction, x direction, what angle it makes? 90. That's why x direction electric field is enough. What is electric field along x direction? At this point, from origin to your distance, what given? B. So instead of x, what we substitute in? B. B I cap. Y j cap does not matter because along z direction flux is 0. Because area is along which direction? X direction, sir. So area, how can you write, nana? Area vector equal to what we can write? The side length L they given. L into L will be how much, nana? L square I cap, sir. Then how to calculate flux, nana? Flux equals to E vector dot A vector, sir. Very good question, nana. E vector dot A vector equal to how much, nana? B into L square. So flux equals to what we can write it, nana? Flux equals to E vector dot A vector, sir. It's nothing but what we calculate in this question, BL square. Sir, what is S7 unit? Your wish 2 units is there, whichever the one you want to write, right? Because we created the example, na? Newton meter square per what you can write, na? Coulomb I can write it, sir. Or volt into meter I'll write, means you can write volt into meter also, no problem in that. Fine. Next illustration is very good illustration, na? They given E equal to xi cap. Sir, what is meant by that means actually, observe here carefully, na? E equal to xi cap, electric field is varying along x direction, they're telling, na? E equal to xi cap means, sir. X direction, okay? Yes, electric field magnitude varying along x direction in this direction like this because x is variable here. And the direction of electric field, which direction? Direction is outward. Magnitude varying along x direction. Direction is which direction, Anna? Along which direction? Electric field direction, k cap. Okay. If you check, Anna, about this point 0 you take. Substitute here. Electric field is 0 k cap. About this point 1 meter you assume 1 I cap, 1 k cap. About this point 2 k cap. About this point 3 k cap. Electric field is variable. Yes, sir, I got one formula. Variable electric field means flux equals to integral E into dA you given, sir. Okay. So, electric field is since varying, you should go with integration, Nana. How to do? We just go up to x, Nana. Up to what you should go? X distance. Take the strip of dx, Nana. One strip you are taking dx. So, on this fellow you find the flux. Calculate the, what you can calculate? Integrate, Nana. So, what will happen, Nana? If you check in this case, Nana, how is area vector? Area vector is out of this fellow, na? For this fellow. Yes, sir, out of that fellow. How can you write area vector, Nana? Area vector equal to dA. Okay, need not write area vector. dA, how to write in this case? Check. dA equal to what you can write, Nana? This is length L, means this is also much, Nana. L into dx. L into dx, sir. Direction can I give, sir? Yes, give direction. Which direction, Nana? It is also on which plane? No? XY plane. Means area vector is along Z direction. Means which direction? K direction. If direction is both of them is same, no? How to calculate electric flux means I just told you. What did I told you? Flux equals to integral. You just multiply EDA or integrate EDA. So flux equals to what you write, Nana? Integral E value much, Nana? X into dA. dA value much, Nana? L dx. Integrate, Nana. If you integrate, what will get? Flux equals to what will get, Nana? L if I take outside, na, you'll get what, Nana? X square by 2 you get it. Sir, how to write the limits, sir? Electric field starting from here going up to here, and it's varying. Means flux is starting from here going up to here, here. Out of that flux will not be there. Side length L means this is origin 0 means this is up to where, L. So I can write the limits from where to where, 0 to L, sir. 0 to L, sir. 0 to L, sir. So flux equals to what you write in this case? So flux equals to L into L square by 2 upper limit minus 0 square by 2 lower limit. So L square into L will be how much, Nana? L cube. So flux equals to L cube by 2 we can write it, sir. SI unit Newton meter square per Coulomb, which we can write it, sir. This is a variable flux we can calculate. So far, even in JEE Mains also, they did not ask variable flux question. This such kind of questions, okay? Very good questions, Nana. Please practice this question once again, okay? Let me take one more example similar to this. What did I given in this example, Nana? I given in this example, what we given, check, electric field value, variable only be given. Sir, how, sir? Side length they given like L, Nana. Okay. But they given what? E equals to E naught into 1 plus X by L K cap. If X value 0, 1, 2, 3, if it's changing, no, E value also changing. Okay. Then what you need to take? You need to take a strip. Okay. You need to take one strip at a distance X from the X axis or origin, Nana. Okay. At this point, you choose the one strip. That strip width is how much you choosing, Nana? Dx. Length is how much? This is length L, this is also much, Nana? Length is L. How to write dA, Nana? Sir, dA vector just now I learnt. length into breadth. Length is how much nana? L. This is dx nana. L into dx. Sir, how to write the area vector? Check the direction how it is nana. How it is direction? Sir, like this is direction. Which direction nana? Positive z direction. Yes sir, no. XY plane means area vector perpendicular to that positive z direction. Okay, z direction this is. If you write now hot, you can write area vector. You can write k cap. Both are same direction, sir. Then I got to know how to calculate the flux. How to calculate the flux nana? Flux equals to closed integral E into dA we can write it, sir, because theta is 0, cos 0 is 1. So flux equal to what we can write in this case? E value. What is E value? E naught into 1 plus x by L into dA. dA value how much? What we can write? L into dx. L into dx. Now open the bracket, integrate. That's it. Answer will get it. So flux phi equal to E naught will go inside. L dx also will come. So what will get? E naught L dx plus integral multiply with this E naught also with this second fellow. This L dx also with second fellow. What will get? E naught x by L into this thing component L dx. If you observe carefully, LL will get a cancel. E naught L is constant. I can take outside. If I take outside, flux equation will get E naught L. I am taking outside. What left? Integral dx. Plus in this case E naught I can take common. What will get? Integral x dx. Sir, limits from where to where? Same limits. From this point to this point is flux changing. Means from 0 to L distance side length. So limits what you can write? 0 to L, sir. Limits 0 to L, sir. Limits 0 to L, sir. Limits 0 to L, sir. 0 to L, sir. Okay. Then what will happen? Check nana. Integral dx going to be much nana. Sir, I know x, sir. Flux equals what you can write nana? E naught L into x. Limits from 0 to L nana. Plus integral x dx is basic integration only nana. X dx is what will become? X square by 2, sir. Very good question we are doing. Before that one E naught is there. Don't forget about that. E naught is there. So 0 to L. So flux equals to what you can write in this case? Flux equals to upper limit minus lower limit. So E naught into L into L minus 0 much nana? L. E naught L square plus E naught into what you can write nana? L square by 2 minus 0 square by 2. L square by 2. So flux equals to what we got in this example? E naught L square plus E naught L square by 2. 3 by 2 E naught L square, which we got it, sir. So this is how we can calculate 2 examples, solid examples I showed you. Very good example, solid means, sir. Okay, based on this JEE Mains EAMCET NEET, they can ask you if question is very difficult also. Okay, like this we can solve. You can ask me a question, sir, for the closed loop, how to calculate flux, sir, for the closed surface. Let me take one example based on this also, nana. Electric field 5 I cap they given, na. What is the direction of electric field? You check, nana. I cap. I cap means which direction, nana? X direction, like this. Okay, this is the direction of electric field, like this they given. Now flux will constitute only x direction faces, nana. Area vector should be along the x. Sir, how means? Let me check. How can we do? If you observe carefully, nana, I am taking for area vector. So this green thing indicates what? Electric field, na? Electric field direction this is, because positive x direction. Area vector direction, nana. Area vector direction for this face what, nana? Outward normal, sir. Because closed surface you told already in basics. Basic, that's why you make your basics strong, I told you. For this field area vector, nana, outward normal. For this field area vector, outward normal. For this field area vector, outward normal. For front one, nana, towards you. For back one, nana, into the screen. Check, nana. Except these both cases, this face and this face, everywhere with the electric field angle is 90, nana. Here you check. This is what? Area vector, na? Electric field on which x? X-axis. So area vector is like this, na. Angle is how much, nana? Angle is 90, sir. So theta equal to 90 means flux equal to how much, nana? 0. Why, sir? Flux equals to EA cos theta. EA cos 90. Cos 90 is 0. So flux equals to 0, na? Yes, sir. We understood. About this below face, we check. Electric field is along x-axis, sir. Area vector downward direction. What is the angle, nana? Theta equal to 90. Flux equals to how much, nana? 0. Flux equals to 0 because EA cos 90. Sir, front face, sir. This face, sir. About this face also flux 0. Back space, sir. About back space also 0 because with the electric field and area vector become 90 degrees. Check carefully. Means these both only constituting what, nana? Flux. Okay. Which faces, sir? The faces which are area vector is along the x direction. Okay. Here diagram became little messy. Let me take one more slide to do this. Like this we got it. E equal to 5 I cap. The portion which I shaded, no, that face only will contribute the flux, nana. How much flux will contribute means we need to check that. Electric field is 5 I cap, now along the x direction electric field they applied like this. Here electric field they applied like this, sir. This is what does indicate, sir? Electric field, sir. And how does area vector will come, nana? This is a closed surface, na? Area vector outward normal, sir, like this. Theta enta, nana? 0 degrees. closed surface na area vector will be outward normal like this area vector. So theta how much? 0 degrees. If you observe carefully, 0 degrees or 180 degrees, 180. Don't do mistakes like this. 180 degrees, which we get it here. About this surface, find the flux ds. If you want to find the flux about this surface, flux at second surface. Let me assume this is second surface. What you can write, EA cos theta. Theta value much, 0. So flux 2 equal to E value. What is E value, 5 into A value much, side length is A, means this is also A, this is also A square, A square will get it. Cos 0 much, 1. That's why flux 2 equal to E 5 into A square. About this surface, how much flux constitutes, 5 into A square. About this surface, how much flux constitutes? Let me check, let us assume that is flux phase 1, What do you get, E into A into, these both are opposite direction. Theta is 180, theta is 180 means cos 180 is how much, minus 1, sir. Minus 1 is, so flux equals to what you get, flux at 1 equals to E value. What is E value ds? 5 into A. Area vector, area magnitude of area for this sheet. This is A, this is A. How much is that, A square, sir. But minus plus minus, sir. This is minus 180. That's why minus will get it. So if I want to check the total flux, sir, I know clearly that flux total equal to flux 2 plus flux 1 or flux 1 plus flux 2, I can write it. Because flux is a scalar quantity, not a vector quantity. So flux total equal to, what we got it, 5A square minus 5A square. So net flux is going to be much, 0. I already told you, right? Electric field leaving, flux should be positive. Electric field entering, flux should be negative. Entering flux negative, leaving flux positive, I told you already. Net flux how much became in this case? 0. Why? Because same number of field lines entering, 5 only, I cap. Same field. Field is uniform means flux is 0 for a closed surface. If number of field lines entering, number of field lines leaving same means flux is 0. Why? Because measure of field lines only on the surface is nothing but electric flux, Okay. Sir, can you give us one more question with the variable electric field along x-axis? Let me create one question, The very important. This question, type of question, very good question I taken. Okay. Based on this NCET example is there. Based on this JEE they asked you. Based on this EAMCET they asked you. Based on this they'll ask you in NEET also, because NCET example question is there. Very important model. So let me check, Same thing we are going to repeat, Earlier what we did, Same thing we are going to repeat. Electric flux you are getting, so electric field value what they even check in this case? Electric field value I cap they given, sir. I cap given means like this electric field is there. Means flux will come through this fellow only. Because for this fellow, how does area vector will come, Like this, If this is electric field, angle is how much? 90. For this fellow, how much, area vector like this, Angle how much? 90. Flux equals how much, cos 90, 0. That's why flux 0. Here also much, 0. That's why if you calculate flux about this shaded portion, this fellow, about this fellow, flux will be enough, So your diagram became a little messy, Let me take one more diagram, We took the one more diagram. The one which I shaded, that one only will contribute the flux through due to this electric field, If you want to check the direction, let me check. Electric field I cap, sir. This is electric field direction. Okay. What is electric field direction? This is the electric field direction. X positive X direction. We got it. Okay. Indicate that there is like electric field. E. This is also what, E. If you observe, next, what is area vector direction, This is closed surface, Area vector outward normal. This should be area vector. Here outward normal. This should be area vector. It is similar to the earlier question. Yes, This is area vector. This is area vector. What is angle at the second face, Theta equal to 0 degrees, sir. Why? Because both are same direction. What is the angle at this place, first face, Theta equal to 180 degrees, because electric field and area vector both are in opposite directions, sir. Okay. Then what we can do, if you observe carefully, about this point you calculate flux. How to calculate flux, Flux at 1 equal to what we can write, Flux at 2. Let me take this first is 2. Equal to what you can write, EA cos theta, sir. Theta much, 0. Cos 0 much, 1. So flux at 2 equal to what we can write, E value much, substitute the value. E naught into 1 plus x by A into area. If side is A means this is also A, this is also A. A into A will be much, A square. So in the place of x, what I have to substitute? From the origin, that face, what distance it's maintaining, check, From the origin, from here to here distance A. About this face I want distance, This is A. And side length A means this is also much, A only. Therefore what will happen? This total distance from here to here. A plus A, 2A, sir. So I'm going to substitute here 2A, A will get cancelled, sir. A will get cancelled means 2 plus 1 how much, 3. So flux 2 equal to what get, 3 E naught into A square. Sir, SI unit, volt into meter you write. Okay. Fine. Sir, can we calculate flux at first surface, sir? Let me try to calculate flux at first surface, How to calculate? Check, flux at 1 equal to what you can write check nana EA cos 180 sir. Why tell me? Because electric field area vector both are opposite direction sir. Cos 180 is how much nana? -1 sir. So flux 1 equal to minus into -1 I multiplied. E value. What is E value nana? E naught into 1 plus x by a. Okay. X by a into area nana. Area of this fellow is how much nana? This is a square. Sir, but in the place of x we did not substitute anything. Let me check. This face is maintained at what distance from the origin? A distance na? You substitute here a. This a cancel na. If this a cancel, what will happen na? 1 left na here. 1 plus 1 how much na? 2. Therefore flux at 1 equal to what na? We can say that minus 2 E naught a square sir. Sir, I know that net flux formula. What is net flux formula? Because flux is a scalar quantity. Flux total equal to what we can write? We just add the flux 2 plus flux 1. Why I choose flux 2 means because here positive is there. That's why. 3 E naught square minus 2 E naught square. Flux total equal to how much nana? What will get? E naught a square. Sir. In earlier question we got the negative flux 0 sir. In this case flux we got it sir. How? Because electric field in earlier question we observed that nana, electric field is constant. Same number of field lines entering, same number of field lines leaving, flux will be same. At entering flux, leaving flux same is net flux how much? 0. But in this example, how much electric field in this case? At this phase 3 E naught, at this phase 2 E naught. Okay, that's why. So flux is different in this case. Okay, net flux how much nana? Not equal to 0, flux total equal to how much nana? 3 E naught into a square, we got it nana. This is the answer for this question nana. Very good question. They asked you in JEE multiple times nana. EAMCET also they'll ask you, KCET also they ask you, NEET also they'll ask you. Please go and practice very well. Okay, yes. Thank you so much for watching this video. Thanks again and see you in next video nana. And before I'm closing the video, I'm telling one thing. Before closing this video, I would like to tell you something. If this video is useful for you people now, please like the video, subscribe the channel and share to your friends also. Okay, hit the bell icon such that you will get next video within the as soon as I upload the video. Bye dear, take care.